Okay, in this problem they tell us that a gas is compressed from 8.00 liters to 3.00 liters at a constant pressure of 2.00 atmospheres. During the compression, 400 joules of heat is added to the system. They want us to calculate several things. We want to find the work done on or by the system in joules, the change in internal energy of the system, and we need to discuss whether this is an exothermic process or an endothermic process. All right, so let's go ahead and write down our data. They tell us that our system is at an original volume. I'm going to go ahead and label that V initial as 8.00 liters. Now, the gas is compressed, the volume goes down. The final volume in this case is 3.00 liters, which means that the change in volume here, final minus initial, 3 minus 8, well, that is a negative 5.00 liters. The other information given is that the pressure that this occurred at is at 2 atmospheres. So let's go ahead and label that P. P equals 2.00 atmospheres. And they also tell us that during that compression, 400 joules of heat was added to the system or absorbed by the system. So heat is given the letter Q. That is 400 joules. And since it's absorbed by the system, that's an endothermic process. So we just answered question C. Endothermic processes absorb heat. We want to go ahead and give that a positive heat value in that case. We want to go ahead and get the work and change in internal energy. So let's go ahead and start by work. The work done in this case is work that's being done on the system. We're compressing this gas, and this is pressure volume work. So we want to go ahead and use the formula work is negative pressure times a change in volume. Work is our pressure, negative, and we're going to use 2.00 atmospheres times a change in volume of negative 5.00 liters. That gives us a value for work as a positive value. Work was done on our system. That's consistent with what we've said in the past. Work done on the system is a positive value. 2 times 5, well, that's 10. And we're in a little bit strange units here. We're 10 liters times atmospheres. Well, it's no problem. We can change this into joules by just using a conversion factor that 1 liter times an atmosphere is 101.3 joules. So let's go ahead. We're going to convert that work by saying 1 liter atmosphere is 101.3 joules. And if we multiply the two, we're going to go ahead and get 1,013 joules, or if we just keep 3 significant digits, we're going to go ahead and call that 1010 joules. So work was done on the system was 1,010 joules. Now let's go for the second part. Let's get the change in internal energy. We can find our change in internal energy by taking the heat that was absorbed by the system plus the work that was done on the system. We're going to add those two factors. The heat absorbed by the system was 400 joules, and the work done on the system was 1,010 joules. So if we add both of those two together, the change in internal energy of our system is a positive 1410 joules. I hope that helps. Take care.